Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss a reduction of aldehyde. Last class I have started chemical properties of aldehyde. Now I will continue from the last class. Now I am going to discuss a reduction of aldehyde. Last class I have discussed nucleophilic addition reaction. Under that I have discussed mechanism of nucleophilic addition reaction, and also I discussed reactivity, and also I have given some important examples of nucleophilic addition and nucleophilic addition elimination reaction, and also I have discussed addition of alcohols. Now I am going to discuss reduction. Reduction to alcohol already I have discussed. It is easy. Many times I have discussed reduction of aldehyde to alcohol, aldehyde and ketone, because both have CO group common, carbonyl group, and some reactions are different, but many reactions are common. Then reduction to alcohol, aldehyde and ketones are reduced to primary and secondary alcohols respectively by sodium borohydride or lithium aluminum hydride, that is LiAlH4, as well as by catalytic hydrogenation. Many times I have discussed this reaction, means aldehyde and ketone will convert to alcohol. Okay, it will reduce to primary and secondary alcohol. Aldehyde will give primary alcohol and ketone will give secondary alcohol. But this reaction will take place in the presence of NaBH4. NaBH4 means sodium borohydride or lithium aluminum hydride, as well as by catalytic hydrogenation. Okay. Then I told you by reduction you will get reduction of alcohol, aldehyde and ketone, you will get alcohol. Particularly aldehyde will give primary alcohol and ketone will give secondary alcohol. Now next things I am telling you, that is the reduction only. This is the somewhat new. Reduction to hydrocarbons, means aldehyde or ketone can be converted to hydrocarbons. The carbonyl group of aldehyde and ketones, the carbonyl group of aldehydes and ketone is reduced to CH2 group, that is also called methylene group. Then carbonyl group of aldehyde and ketones is reduced to CH2 group on treatment with zinc amalgam and concentrated hydrochloric acid. This is called actually Clemson reduction. CLEMMENACN, Clemson reduction. Okay, this is very, very important reaction, Clemson reduction. And other condition is also there. By that way also you can get hydrocarbons from aldehyde and ketone. That is actually called Wolff-Kishner reduction. Wolff-Kishner reduction, WOLFF, Wolff-Kishner, KISHNER NER reduction, Wolff-Kishner reduction. Then what is condition for Wolff-Kishner reduction? That I am telling you. Hydrazine means this reaction will take place in presence of hydrazine followed by heating with sodium or potassium hydroxide in high boiling solvent such as ethylene glycol. If you will maintain this condition, then this is called Wolff-Kishner reduction. Okay, in both condition you will get hydrocarbon. Hydrocarbon you will get. Then when you are using zinc amalgam with concentrated sulfuric acid, hydrochloric acid, ZnHg with concentrated HCl, then that is called Clemson reduction. Then you will get hydrocarbon, means a COO group of carbonyl present in aldehyde and ketone, that will convert to CH2. Okay, means you will get hydrocarbon, because any aldehyde COO, one side H, other side this in aldehyde RCHO you can tell, RCHO, then RCOO is there, then H is there, then this COO will convert to CH2, this C double bond O, that O will convert to CO will convert to CH2, then you will get hydrocarbon. Everywhere carbon and hydrogen is there. Same thing will happen in both condition, means by Clemson reduction or by Wolff-Kishner reduction you will get hydrocarbon. Reaction is very simple. Just main is the carbonyl group will convert to CH2. Then here CO group in presence of ZnHg, zinc amalgam and HCl, it will convert to CH2 plus H2O, because reduction means it will supply hydrogen, and in CO O is there, then H2 plus O, it will form H2O, then O will go as H2O, and in its a double bond was there, C and oxygen, there was double bond, this bond broken, then now here in the place of two double bond, now two hydrogen can join, okay, because ZnH amalgam in presence of HCl will supply hydrogen, hence this O will convert to H2O, and H will join to carbon, 2H will join to carbon. Okay, total there is a use of 4H, 2H gone with 1 O as H2O, and other 2H joined with carbon, and it formed CH2. Then this 4 hydrogen was supplied by this ZnHg HCl, correct? That has supplied with reduction. Reduction is supply of hydrogen. Then this reaction is known as Clemson reduction. Now another I told you, Wolff-Kishner reduction. There also this reaction will take place in two steps. In first step, same reaction only, condition is changing. Here you are taking hydrazine, NH2. Then now you can understand very easily. NH2 is there. Then H2 of 2 NH2 is there. NH2 means N already double bond is there, and with each N 2 hydrogen is there. Then 2 hydrogen of 1 nitrogen will join with water. with oxygen of CO, and it will form water. Oxygen of CO that will convert into water. Okay, hydrogen will come from the H2, NH2, that will supply to hydrogen, and one oxygen is already there with the carbonyl CO, hence it will form H2O. And there now what will happen? Now N will join, because hydrogen, when hydrogen left the nitrogen, then it went without hydrogen, without this electron. H2, as H plus it went, leaving its electron to nitrogen. Nitrogen has now 2 pair of electron. Nitrogen is negatively charged. Now when CO bond broken, that time oxygen went with its electron. C double bond was there, then both bond broken, then oxygen went with electron. Then now carbon is positive, then nitrogen, which is negative, will join to the carbon with a double bond, because both are in a position to form double bond. Nitrogen has two pair of electron, that will give to the carbon, and double bond will be formed. Then now here you will get that oxygen gone, in its place nitrogen came and made double bond with carbon. Then now you got C double bond N, again N was already N, NH2 was there, then only one H2 went and joined with carbon. Then C and N, first nitrogen double bond. After that nitrogen already double bond was there, and with that nitrogen, last nitrogen, second nitrogen, hydrogen was already there. Hence you will get C double bond N, and again with this N, NH2 is joined with double bond. And now this is actually it is not very stable. This double bond will break in presence of KOH or ethylene glycol. Ethylene glycol, that is the high boiling point solvent. Then in presence of this KOH and ethylene glycol, and you have to heat it, then what will happen? This double bond will break. This carbon nitrogen double bond will break, and here H2 was attached with the second nitrogen, that bond also will break. Correct? Then now nitrogen will go NN, that as a N2. It will go. Nitrogen was already NN double bond was there, but when you can say this carbon nitrogen bond will break, and both hydrogen bond will break from the another nitrogen, then it will go as a N2, because hydrogen will go, then it will go as a H plus, then 2H plus, it will go as a 2H plus. Then this hydrogen has a hydrogen lost their electron, it is taken by nitrogen. Hydrogen N and H bound, that electron is taken by nitrogen, 2 electron. Again one more bond was there, NH, that also left, and electron was taken by nitrogen. Correct? Then now here you can see hydrogen actually as a H plus, it left 2 hydrogen. Then when this double bond of carbon, when this will break, then what will happen? That with this carbon now 2 hydrogen will join. correct? Here one nitrogen, what will happen, that one nitrogen in any case, when carbon and nitrogen bond will break, double bond, then if nitrogen takes electron, because nitrogen is electronegative, then it will take the electron, then carbon will be positive. Carbon will be positive. In that situation, when nitrogen is negative, taken the electron, then hydrogen will go as a H minus. When this side nitrogen, any one side nitrogen will take the electron, not from both sides. Not from both sides, only from one side it will take the electron, correct? And because it will get, you can say electron, two electron pair is there, two electrons will, finally it will get. If suppose carbon and oxygen double bond breaks, then carbon and double bond nitrogen, that bond is breaking, then suppose nitrogen has taken electron, then carbon will be positive. Then in that situation, because nitrogen already got 2 electron, then that 2 electron that electron will be used in making nitrogen triple bond, third bond. That is a triple, already 2 bond was there, N double bond, now it will become N triple bond. Then in that situation, hydrogen will go with electron as H minus, hydride ion as H minus. And otherwise, if you can say NH bond, H is going as H plus, correct? Then nitrogen will be with this nitrogen. Then these two electron, well, actually already nitrogen will take its electron. Then 2 hydrogen gone with leaving their electron. Then extra 2 hydrogen it got. That electron will be used up in making third bond between nitrogen and nitrogen. In that situation, when hydrogen is going as a H plus, then this C and N bond, when it will break, that time carbon will be negative. It will form anion, anion. That's why now N is triple bond, it will go as a N2 gas, and carbon is now becoming negative. Then hydrogen will be positive. And when hydrogen will be positive, then carbon will be negative. Any one will be negative. Then reasoning I told you, when C and H bond will break, then because bond is breaking from both sides, C and N bond also, or N and H bond also, then any one nitrogen will be negative. Any one nitrogen will be negative, okay, not both. Then suppose carbon nitrogen bond is breaking, then if suppose nitrogen is taking electron, then carbon will be positive, correct? Then here NH bond, in that situation it will break, then it will go as a H minus, and that 2 H minus will come to the carbon 2 plus, okay, and it will make CH2, okay, means it will form hydrocarbon. CO converted to CH2, other product is N2, nitrogen gas. This is called Wolff-Kishner reduction. Here again I am telling you, already I told you that whenever name reaction comes, it means that their mechanism is different. Correct? That's why a special name is given, because in that reaction mechanism will be little different, unusual, but in general reaction it will be usual, correct? Hydrogen generally it will go as a H plus, generally 90% cases, but sometimes it will go as a H minus also as a hydride ion. You remember these things, okay? Then here these things are happening, okay? Then in all you can say name reaction, something will be new, special. Then this I have told you, reduction of reduction means this aldehyde and ketone. Aldehyde will convert to alcohol. Aldehyde and ketone both will convert to alcohol. First reaction I told you. Second, that aldehyde and ketone will convert to hydrocarbons. Then both name reaction, Clemson reaction and this Wolff-Kishner reduction I have told you. Okay, both reduction, Clemson reduction and Wolff-Kishner reduction, both are very, very important for all examination. Question is always asked. Now next properties I am telling you, chemical properties of aldehyde and ketone, that is the oxidation reduction. Only oxidation we can tell. Oxidation reaction. Okay. Aldehydes differ from ketone in their oxidation reactions. This reaction is very, very important. Remember, this oxidation reaction of aldehyde and ketone is very, very important reaction. Now listen carefully. Aldehydes differ from ketones in their oxidation reactions. Aldehydes are easily oxidized. Aldehydes are easily oxidized to carboxylic acid on treatment with common oxidizing agents like nitric acid, potassium permanganate, potassium dichromate, etc. Even mild oxidizing agents, mainly Tollens reagent and failing reagents, also oxidize aldehyde. I told you two extra reagent, that is the Tollens reagent is oxidizing agent and failing reagent is also oxidizing agent. Then these two agent plus carboxylic acid, not nitric acid, potassium permanganate, potassium dichromate, these are also function as oxidizing agent. 5 example I am telling. I told you about the oxidizing agent: nitric acid, potassium permanganate, potassium dichromate, and 2 more, that is the Tollens reagent and failing reagent. Correct? These 5 oxidizing agent oxidizes aldehyde, and this aldehyde will convert to carboxylic acid. What will happen? Already RCHO is there, aldehyde. One more oxygen will introduced here. Simple. One more oxygen will introduce here and it will become RCOOH. CHO will convert to COOH. Extra O, one oxygen came. But always remember, in acid, in carboxylic acid, one oxygen will have double bond. It will be attached to carbon with double bond and other oxygen with single bond. Okay. Then oxygen is 2 valence. When it is attached with a single bond with carbon, then other valency will be attached with single bond of hydrogen. Means C double bond O, and other oxygen C and O single bond, and that O is attached with H. Okay. Then here CHO will convert to RCHO will convert to RCOOH. Means you will get carboxylic acid. Now come to the ketones. This I told about the aldehyde. What will happen to the ketones? It is different. Ketones are generally oxidized under vigorous condition. Vigorous means more drastic condition, you can tell. Okay. Ketones are generally oxidized under vigorous condition, that is strong oxidizing agents and also temperature is required. High temperature is required. Ketones are generally oxidized under vigorous condition, that is the strong oxidizing agents at elevated temperature. Their oxidation involves carbon-carbon bond cleavage. For that purpose, high you can say strong oxidizing agent or high temperature is required, because carbon-carbon bond will break. This is the important things here. Their oxidation involve carbon-carbon bond cleavage to afford a mixture of carboxylic acids having lesser number of carbon atoms than the parent ketone. Means here at least more than 2 carbon is required, means 3, 4. Then when carbon-carbon bond will break, then obviously that in comparison to the parent, now when bond will break, carbon-carbon bond, then you will get compound which will have 1 carbon less. 1 carbon less. This is the can say special things of ketone oxidation. Okay. Here in ketone oxidation involve carbon-carbon bond cleavage, means breaking to afford a mixture of carboxylic acids. Here also you will get carboxylic acid, but mixture you will get having lesser number of carbon atoms than parent ketone. As for example, you take example of these things, just like you can say you consider acetone, CH3CO, CH3, C and O double bond. Then now suppose CH3 is there, then both side, suppose one H gone and one R has joined, both side. Then it become RCH2, other side also RCH2. In the middle CO is there. Then now here 3 carbons are there including CO, you can say 1, 2, 3. C is in the middle, CO is in the middle, left side 1 carbon, second side, left side 1 carbon, right side 1 carbon, and both side with carbon 1 and carbon 2, carbon 3, carbon N and carbon 3, R and R dash group is attached. Different alkyl group is attached. One with carbon 1, one alkyl group is with carbon 1 and other alkyl group is with carbon 3. In the middle CO group is there. This you just to consider that oxidation is going for this compound, this ketone. This is the ketone. Why? C and O double bond is there. This is a ketone. Then now suppose oxidation is going on in presence of a strong oxidizing agent. Then now carbon-carbon bond will break. Correct? Then what you will get when carbon-carbon bond will break? First of all, you know that CO will convert to COOH, no problem in that. Then you will get here RCOOH, and other will be R dash CH2 COOH. CH2, actually CH2 was both side, only from that CH2 R dash has joined with third carbon and R is joined with the first carbon. Then RCH2 is in both side, but here carbon bond is broken. Then you will get R COOH, correct? Means CH2 and C means first and second carbon bond will break. Bond between carbon 1 and 2, that will break. CH2 and C, middle carbon and first carbon bond will break. Then what will happen? That this when bond breaks, then one CH2 one CH2, and only here bond is breaking, then CH2 is there, then that CH2, because oxidizing agent is there, that will supply oxygen, then that CH2, that H2 will convert to water. H2, one H will be there, one H will be there, and there what will happen, that when C and O bond, carbon-carbon bond broken, then there due to that breakage of bond, carbon was having positive charge, oxygen has come, two oxygen will join, one due to this carbon bond cleavage, due to that one oxygen, and other oxygen will join also, but this oxygen, second oxygen will join this here, two oxygen will join, then one oxygen will join as you can say double bond, C double bond O, CO, and two hydrogen was there, CH2, then one hydrogen bond will break, and carbon oxygen will join, new oxygen, second oxygen will join with carbon, and only with that oxygen one H will join, only one H removed from CH2, one H will be with that carbon, but that position changed, that bond, two hydrogen bond, both bond broken, then one oxygen came, they made double bond, correct, because CH2, two hydrogen was there, when this two hydrogen bond will break, then one oxygen can join with a double bond, making double bond, one oxygen can join, then double bond is formed. Now one positive charge is there till date with carbon, that is due to when carbon bond broken, that due to that carbon, when bond broken, carbon, then carbon will, that time carbon became positive, then now oxygen, one oxygen atom will join by single bond with this carbon, and other valency will join with hydrogen, correct, out of two hydrogen, one hydrogen will join, now one hydrogen is remaining, remember, then now you got RCOOH, one carboxylic acid you got, now I told you will get a mixture of carboxylic acid, then one carboxylic acid you got, now another carboxylic acid automatically you will get, because when the carbon bond broken, then that time CO, where C and O double bond was there, carbonyl, that part I am talking about, that part carbon is now negative, because anyone will get positive, two carbons are breaking, then one carbon will be positive, other carbon will be negative, but here negative will be that carbon to which oxygen is joined, because oxygen is electronegative. Then now here what will happen, already carbonyl group is there, then now due to the oxidation one oxygen will come, that oxygen will join with actually here again I am telling you that here, because it is also forming RCH2COOH, that you can say you will get acid, carboxylic acid, then already one double bond is there, COO, and one H plus is there, then what will happen, that because that carbon oxygen double bond CO, that bond will break first, then carbon will get positive charge, oxygen will get negative charge. Then hydrogen will H plus, one H plus was there, that hydrogen will come and will join with oxygen, correct? Then now it became COH. And now that one oxygen will come through the oxidation process, one oxygen will come and that will join with carbon, that will join with positive carbon, and it will form COOH. Okay, then here you have seen, then you got RC double bond O and OH. Okay, or very simple way you can understand that if you think in a that when bond breaks and takes one electron like a radical formation, then very easily you can understand, both ways you can understand. Then when when carbon bond broken, then one carbon was taken by both carbon, very simple way, correct? And when both hydrogen will CH bond will break, then now again carbon will get 2 more electron, means on carbon total 3 electron will be there, and hydrogen will take one electron, correct? Carbon has 3 electron and hydrogen has 2 each has one electron, correct? Now here that carbon to which CO is attached, now that carbon is also having 1 electron. Then now this carbon has only 1 electron. Then what will happen, that if oxygen will come, new oxygen will come, then it will have 2 electron, then that it will go to the first part of the RCS2 there, then 2 electron of oxygen and 2 electron of carbon, first part carbon, they will make double bond, clear? COO bond is formed. Now despite that on this carbon 1 electron is there, then now second oxygen will come, second new oxygen, then it will have 2 electron, then 1 electron it will share with carbon third electron, then one electron of carbon, 1 electron of oxygen, it will make single bond. Then now that oxygen now is having till date 1 oxygen it is having. Then now 2 hydrogen was there, then 1 hydrogen will come with 1 electron and it will make bond with this oxygen having 1 electron. Then now you got RCC double OH. Now you got RC double bond, 1 double bond, and now OH. Then one in mixture 2 acid you will get, then first acid is RC double OH due to the first part of cleavage of carbon-carbon bond. Now come to the second part. That carbon, CO carbon has 1 electron. Then that electron will make a bond with now new oxygen, means third oxygen will come, then that will have 2 electron, then that actually 1 electron of oxygen will join with 1 electron of carbon, CO group, that carbon 1 electron was there and 1 electron from the new third oxygen, they will make OH, OH bond, correct, and not a CO bond, C and O. One electron from the CO that was having one electron, that, and oxygen one electron. It has two electrons. Then O and C will make one bond. Till that now one electron is there on the carbon. That carbon as this oxygen and carbon joined. Then now oxygen also has one electron. That electron and hydrogen, two hydrogen left, that hydrogen also have one electron. That will make bond with this oxygen one electron. Hydrogen one electron and oxygen one electron. They will make OH bond. Then now see, second carboxylic acid also you got. Radical wise also you can understand, charge wise also you can understand. Any way which you feel, that way you can understand. You can understand any way. Charge wise also you will find it is finely neutralized, and electron wise also all electron will be neutralized. Then here you will get ketones. Oxidation of ketone will give the mixture of two carboxylic acid. Then here in this example you will get RCOOH plus R dash CH2 already was there, CO group, carbonyl group was there, and new OH bond formed. Then you got the mixture RCOOH plus R dash CH2 COOH. Okay, due to the cleavage of carbon 1 and carbon 2 bond. Then this I have told you about the ketone. The mild oxidizing agents, I am telling you now, especially I will tell about the tolerance reagent and failing reagent. Always question is asked, always. Then now actually both are mild oxidizing agent. The mild oxidizing agent, they will with the use of this means tolerance reagent and failing test. You know, tolerance reagent test and failing test. Then by these two tests you can distinguish aldehyde and ketones. How will you distinguish aldehyde and ketone? Then by tolerance reagent and failing reagent, or you can tell by tolerance test and failing test you can distinguish aldehyde and ketone. It is very, very important question is asked. Then now first I am telling you tolerance reagent. Tolerance reagent, what is the tolerance reagent? First you understand, then what is the test, that you will understand. Then tolerance test you understand, and I will tell you what is the reagent, tolerance reagent. Then here on warming an aldehyde, what is the test, only in that I will tell you reagent also. On warming an aldehyde with freshly prepared ammoniacal silver nitrate solution, this is actually tolerance reagent. Ammoniacal silver nitrate solution means AgNO3 in ammonia. That simple way. Okay, silver nitrate means AgNO3 in ammonia. When it is dissolved in ammonia, that is called ammoniacal silver nitrate solution. Then on warming an aldehyde with freshly prepared ammoniacal silver nitrate solution, a bright silver mirror is produced. A bright silver mirror. Silver always will shine, you know. Bright shine you will get of silver. Correct? This from where you are getting this bright shine, then you are getting due to the silver, because in this reaction silver will be produced, that will shine. Okay. Then on warming an aldehyde with freshly prepared ammoniacal silver nitrate solution. A bright silver mirror is produced. Silver mirror is due to the silver formation. A bright silver mirror is produced due to the formation of silver metal. The aldehydes are oxidized to corresponding carboxylate anion. Already I discussed same way, because it is oxidizing agent, it will supply oxygen. Tallest reagent is mild oxidizing agent. Then aldehydes are oxidized to corresponding carboxylate anion. In that is the any acid RCOO1 minus. If H is not there, H plus, suppose it is ionized as H plus, then what is remaining? RCOO1 minus. That is called this carboxylate anion. Carboxylate anion. Okay. The reaction occurs in alkaline medium. This reaction will take place in alkaline medium. What is the reaction? Reaction is also important. I am telling you. RCHO is aldehyde. RCHO plus AgNH3 whole 2. AgNH3 whole 2 is a complex. AgNH3 whole 2, that you can write in a big bracket outside plus, because this is the complex ion. Okay, it is the complex ion AgNH3 whole 2. This you write it in the big bracket outside 1 plus. Then RCHO plus this complex, two molecules of this complex will react, and because reaction is taking place in alkaline medium, hence OH will be also there. Then three you can say reactant will be there. First reactant is RCHO. Second is complex, silver complex of ammonia. Okay, there is the complex compound, two molecules of AgNH3 whole 2 plus 3 OH minus. When it will react, it will form RCOO minus, means anion, carboxylate anion, plus 2Ag plus 2H2O plus 4NH3. Now, why you have taken two molecules of silver complex? Now you are understanding, because it will finally in the final reaction it will give 2Ag in the form of metal, 2Ag, and here NH3 whole 2 was there, and outside 2 molecule was there, then total became 4NH3. That is this complex will break and it will give 4NH3, and 3OH was there, alkaline medium, 3OH. Then that 3OH will convert to 2H2O, water molecules. Here in 2H2O 4 hydrogen is required and 2 oxygen is required. Then here you will get, here you have 3 OH, 3 oxygen is there, and 1 oxygen is with RCHO. Total 4 oxygen is there. Then 2 oxygen will come, 1 oxygen from the OH will come to the CHO, and it will form RCOO. Then only 2 oxygen is remaining. Correct? Then hydrogen is 3, oxygen is 2. Then from where 1 hydrogen will come? Then that hydrogen will come from the RCHO, that hydrogen. That's why it will form 2H2O. Then like that way you will get a balanced equation. Okay. For product RCOO1 minus plus 2Ag plus 2H2O plus 4NH3. This I told about the tolerance test. Okay. Then aldehyde is giving silver mirror. This is also called silver mirror test. Now come to the failing test. failing reagent. Here failing reagent comprises of two solutions. What is the failing reagent? Then that you understand. It is the mixture of two solutions. What are that two solutions? Then failing solution A and failing solution B. What is A and B? Then failing solution A is aqueous copper sulfate. A is aqueous copper sulfate and failing solution B is alkaline sodium potassium tartrate. Two part is there. Aqueous copper sulfate dissolved in water, that is called aqueous copper sulfate. That is the A, failing A, and failing B is sodium potassium tartrate. Actually this sodium potassium tartrate is solid. When it is dissolved in alkaline, means in alkali like basic medium NOH or KOH, that is called alkaline solution of sodium potassium tartrate. Sodium and potassium tartrate is also called Rochelle salt. Question is asked, what is the Rochelle salt? Then sodium potassium tartrate is called Rochelle salt. Then this is called B, failing B solution. Now if we will mix both solution A and B, these two solutions are mixed in equal amounts before test, then that is called failing solution. Failing solution. On heating an aldehyde with failing reagent, when aldehyde you will take and you will heat, on heating an aldehyde with failing reagent, a reddish brown precipitate is obtained. Reddish brown color if it is giving, it means aldehyde is present. Reddish brown color is the sign of aldehyde. Okay. Aldehydes are oxidized. Aldehydes are oxidized to corresponding carboxylate anion. Aromatic aldehyde do not respond to this test. This you remember. Aromatic aldehyde, benzaldehyde, it will not give this test. Then this is a very, very important test of aldehyde. Means its reaction is RCHO. Again here three reactants are there. Aldehyde means RCHO plus 2Cu. 2Cu2 plus copper sulfate, that cupric ion, plus 5OH minus. 5OH minus. Correct? Then here three reagents are there. RCHO plus Cu2 plus 5OH minus, and it will give three product. First product will be carboxylate anion RCOO plus Cu2O, cupric oxide Cu2O. Correct? Then in cuprous oxide, here Cu2O is there. Then here 2 copper is required. Cu plus 1, only 1 plus. Cuprous oxide, and its color is red brown. It will settle down as a precipitate Cu2O with oxygen 2 Cu1 plus. Cuprous is attached with 1 oxygen, 2 copper. Then cuprous oxide, its color is red brown precipitate, and third product is water, 3H2O. Then this I have told you about the failing reagent and tolerance reagent. Now come to this ketone. What will happen with the ketone? Then oxidation of methyl ketone by halophone reaction. Oxidation of methyl ketone. Okay, third reaction I am telling you. Then here aldehyde and ketones having at least one methyl group linked to the carbonyl group, carbonyl carbon atom that is called methyl ketones, are oxidized by sodium hypohalite. It is oxidized by this methyl ketone. This methyl ketone means aldehyde and ketones having at least methyl group, that is the condition. They must have methyl group, at least one methyl group, a methyl group linked to the carbonyl carbon atom, that is called methyl ketones, are oxidized by sodium hypohalite. It will oxidized by sodium hypohalite, and it will give sodium salts of corresponding carboxylic acids having one carbon atom less than that of carbonyl compounds. The methyl group is converted to haloform. Haloform, just like a chloroform is their example of haloform is chloroform. Halo means halogen. It will convert, the methyl group is converted to haloform. This oxidation does not affect carbon-carbon double bond if present in the molecules. Okay, when then means its reaction is very easy. RCOOCH3 in presence of NaOX. NaOX. Okay, X is halogen. NaO is sodium phenoxide. Not simply sodium oxide. NaOX. Okay, oxyoxide, sodium oxyhalide you can kill. Then in the presence of NaOX, now what will happen? That NaOX, then that OX bond will break. S will be negative, X will be NaO. It will break, X will be negative. But here it will be oxygen will be negative because X you don't know which X is there. If fluorine is there, only then it will be negative, and oxygen will be positive because oxygen is the most electronegative element. But in this case, in general way, now what will happen? RCOO is there, that ONA group will come in the place of CH3. CH3 means CH3 will go as a negative, and NaO will also be negative. Hence easily it can substitute in the place of CH3, ONA will join, and CH3 which is negatively charged here, CH3, that will join with X plus, because NOx, that NO is negative, then X will be positive. Then that X, this X positive will join with CH3, which is negative, and it will form CHX3. X may be Cl, Br or I. Correct? Then same way you can understand another reaction. Carbon-carbon double bond is there, with but with each carbon double bond, carbon methyl group is there on each carbon. Correct? And again with that, already what I discussed, COCH3 is there. COCH3 already there, then you have to give value for this COCH3. That double bond carbon, that simply is a one group. Then here again same way it will react, that Ca in the place of CH3 ONA group will come. ONA group will come. Okay, that's enough. And that CH double bond will be as it is. It will not disturb. Only CH in the place of CH3 ONA will come, and this CH3 which is negatively charged, now Cl plus, same way what I discussed, it will join with CH3. Cl plus will join with CH3 minus anion, carboanion, and it will form CHCl3. This is actually chloroform. CHCl3 is known as chloroform. Just like iodoform, in the place of Cl, if I3 is there, CHI3, that is called iodoform. Iodoform reaction with sodium hypoiodate is also used. Iodoform reaction when in the place of chloroform, if iodoform is forming, that is called iodoform reaction. Iodoform reaction with sodium hypoiodide. Sodium hypoiodide is also used for detection of CH3CO group or CH3CHOH group, which produces CH3CO group on oxidation. Okay. Then now I am stopping only here. Next class again I will continue this chemical properties. Actually it is many chemical reactions are there, properties are there. Then whatever is remaining, that I will discuss next class. Thank you.